Okay, so yeah, as Ferdinando said, I'm Gabriele Corsi, and I'm the CTO, so I'm the most technical figure here. So I will show you what are the tips and guidelines you should follow to instantiate your the MAMWLE model in your custom design. So let's move on. We faced a lot of problems in the last year, as Ferdinando can confirm, when we tried to implement LoRaWAN communication in our first project and sensors, because LoRaWAN, even also because that was the first years of LoRaWAN spreading, so there wasn't so many documentations, but there wasn't models which were able to ease all the process of implementation of this technology. So one way would be going from the A to Z, implementing your own solution, starting from the microcontroller, going through the Semtech and LoRa transceiver with all the RF matching, with all the passives, crystals, RF switch, and so on. So you would have a very complex design, which are possible only for people who are who have a strong experience in RF design and architectures. Or you can go simply with this model. So this model integrates everything in a very small footprint. You can see it by this picture. So that is the model that you could use to ease all the implementation process, right? So let's see what are the features that makes a model perfect in some way. As you can see, the architecture of the model, it's in this picture. So there is the brand new STM32WL, which is the microcontroller which integrates Cortex M4 and an M0 Plus, which are both accessible by software and firmware. So you can choose how to use them independently. If you want the Cortex M4 to use the radio, you can. If you want the Cortex M0 to use it, you can either. So it is all integrated in one single chip. It comes with a great computational power. So that was one of the key aspects that pushed us to design a new model. We needed a high computational power, which wasn't able to, which wasn't on the Cortex M0 Plus, which is done for very low power applications. So that's the key aspect of this model. Another thing is the high stability that you want with a model. In this model, there is the we decided to go for an integrated TCXO, which is a temperature compensated oscillator. That is very important when you want to deploy this model on a sensor or on a custom PCB that has to work in really harsh environments. So high temperatures, high humidity, or everything you want, because you want to have high stability in every condition. And that's very important also for the sensitivity of the radio, because of course, deviation on the frequency of the radio will lead to lower sensitivity. And the extremely high sensitivity is one of the key aspects of LoRaWAN, so you want to miss it. Another thing is the low power consumption. We decided to integrate inside the model the DC-DC converter to make it the most efficient as possible. So we had two choices, but we wanted to integrate all the components that you need inside the model. So every switching components regarding the DC-DC converter are just inside the model, and you don't have to implement them outside. So there is everything inside. Another key aspect, of course, is the compatibility. As Ferdinando said, you have the compatibility for LoRa, GFSK, GMS-SPK, and so on. So you literally can do anything with this model. The other key aspect that we wanted to this model to have is the capability of going through high and low power. So we maintain the two TX, the two transmission paths that comes with the STM32WL inside this model. So, of course, if you are in Europe and in most countries, you can't use the high power the high power transmission path, of course, because you would go against the regulations. But in countries like US and Australia, that you can where you can transmit up to 30 dBm, you will find very, very useful to this feature, because it allows you to transmit at higher powers if you have to cover even wider environment. So it is a very nice feature. Another key aspect that is a key fact is the worldwide frequency plan on a same model. That is not an easy thing, because with one model you grab also the compatibility, the worldwide compatibility. So that means that you don't have to have a different assembly line for every different country where your sensor will be deployed, but you can maintain only one assembly line, so only one component to handle for a worldwide compatibility. You will only choose by software, so the band to where the model has to operate by software. So that is a freedom which is very, very important, especially if you are a worldwide company, of course. And doing that, we maintain perfect RF matching parameters, even with a wide bandwidth. Why the others, often doesn't offer this capability, because it is a bit complicated to implement a wide bandwidth RF matching. So perfect transmission parameters on a wide bandwidth. That is because it's very complicated in a very, very shrink design. I don't want to go in details, but you need more components to widen the bandwidth of a model. And we was able to do it even in a very, very small design. So it's a very great thing, we think. The model comes with two variants. One is the 0 and the other is the 1. So these are two variants which are different for the antenna output. The 00 version goes with the micro FL connector, so the coaxial connector. That is the easiest way to implement a design, because you don't have to handle any RF component, because it is everything inside the model. You just only have to attach your antenna with a micro FL connector or a micro FL pigtail, and you are on, just like that. If you want to implement a different solution, for example, if you want to go for a cheap antenna or PCB antenna, which could come very, very important if you are in a very small, compact design, you can go and get the pad antenna version, which is the 01 variant. So in that way, you will route the RF pad outside of the model with your RF matching circuit. So you have the complete freedom of for it. So that's another versatile thing that we offer with it. As I said, all of these comes with a very, very small footprint. So it's not, as I said before, it's not an easy thing, because we integrated so many things inside the model, having the GPIOs unaltered and having the dimension very, very low. If you have to do a design which is really, really integrated, which have to have very, very small dimensions, with this model you can do it without having to have compromises. That's the key point. As I said, everything comes with high GPIOs count and a bunch of serial communications that comes with it. So you have 36 effective GPIOs. You have E2Cs, you have SPIs, you have UART, you have timers, of course, you have ADC, DUCs, you have everything. You have just everything. So you have the complete freedom of choosing several different peripherals, because you have the resources to handle them. That's a very, very great thing. Another thing that a model could have is the certainty, which is I think that if you are a hobbyist, probably you don't mind a lot about it, because of course the prototype has to work, but it doesn't have to be certified, or it doesn't have to go in mass production. But if you are a company which have to deploy a lot of sensors worldwide, you have to get the you have to be sure that your design will work and will pass the certifications, preferably at the first attempt, of course. So with this model, as you can see by this slide, we passed all the certifications in a great way. So all the radiated emissions are far behind the limits. Of course, the 86.7 megahertz tone is above the limit, but that's the tone that we radiated during the transmission. So that's not the, you know, that was not counted on the certification, of course. So Our model comes CE certified with all the radio standards that are here in Europe. We are also going through FCC certifications, of course. So soon we will get it as well. And that's so why I talked about certainty. Why using this model, you are 99% sure that you will pass the certification, of course, regarding the RF aspect of your board, because everything is integrated inside the model. Every component is just placed and routed in the way that it will not have any problem regarding EMI and EMC. So signal integrity problems or something like that, you will not face anything regarding that. It's all integrated inside the model. Especially if you choose the micro-FL connector variant, everything that is radio frequency is contained inside the model, and you literally can do anything outside the model, because RF will not lead you to any problem, of course. Another thing that even in, especially in this period, it's a very, very huge problem. It's the component supply chain. There are a lot of problems, as you can see, on the supply chain. So grabbing components, it's quite impossible in these times. So you will have a lot less problems on supply chain, because you have to handle only one component instead of 30, 40 that you would have if you go for a proprietary RF interface. All right, and also the cost. We go for every expensive component. So when you will buy our model, you will have all the expensive components inside it, right? Yeah, that was the point that Ferdinando pointed out. Our model, we assure, is the model that has the higher feature over power, over area capabilities ratio. So if you want to have more GPIOs, you have to go for extremely big modules. If you want to go for little models, you will have to shrink the capabilities, so the GPIOs and all that comes with them. So that, we think, is the best trade-off regarding the model panorama.